Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from Group 6. We will present about application of first ordinary differential equations to kinematic analysis of rigid body dynamics. The the using Newton's second laws, sigma F is equal to ma. Okay, our member are Afrian, Frizky, Alanda, Khoirul, Mubin, Fatyadi, it's me, and Lutfi, Anggito, Wicaksono, Aji. This body motion under strong influence of gravitation. There are many engineering systems that involve dynamic behavior under strong influence of gravitation. Example, the examples are rocket launch. You know that rocket, rocket when they launch use rigid body motions, and then paratroopers and helicopters. Okay, next, rigid body in vertical motions. Uh, in the past, Galileo Galilei do the experiment of free falls experiment from the leaning tower in Pisa. You can see from the pictures, Galileo uh, falls the ball from the Pisa Tower at December 6012. Math modeling of it is okay. Next, there are two experiments: free falls and drop. When free falls, the acceleration, the ball is accelerated by gravitation velocity. You can see velocity go down 50, and there are two there are two force, then their weight and F, and also RT. For the thrown up, the acceleration is declarations by gravitations because the movement is go up. Solutions show the instantaneous positions xt. We can we can suppose it's as xt, the instantaneous velocity as vt, the maximum height the body can reach, and the required time with initial velocity f0 v0, I mean, in the turn up situations. The next, solution of experiment can be obtained by first deriving the mathematical expressions. It's a differential equation in this case, and solve the solutions by kinematics of moving solid. If the instantaneous position of solid is expressed as xt, we will have Vt is equal to dxt over dt to be instantaneous velocity, and for accelerations, the instantaneous acceleration is at is equal to d vt over dt. We do first derivations of vt or declarations. You can say acceleration or declaration. Acceleration for free fall and declaration for turn up. Okay. Next is derivation of math expression for free falls of a solid that will explained by Lutfi Anggito. Okay.
Okay, thank you, Mubin. I will explain the next material. So for the derivation of math expression for free fall solid, from the figure we can see that the ball is having a force that is weight, and it is symbolized by W. It is weight, and there is RT, that is the resistance of the air on the falling solid, and Ft, that is the dynamic or inertia force, due to the changing velocity of the fall under gravitational acceleration. We can see that the Ft or the inertia has a different direction with the velocity because it is the properties of an inertia of an object. So the weight of the body is equal W equals m times g, in which m equal mass of the body and g is gravitational acceleration, that is g equals 9.81 meters over second square. So this force is always points to the center of the earth. And the next is the resistance encountered by the moving body in the medium such as air, that is RT equals CVT, in which C is the proportional constant determined by the experiments and Vt is the instantaneous velocity of the moving body, and RT act opposite to the direction of motion. The next is the dynamic or inertia force, Ft equals mat, in which at is the acceleration or deceleration with a negative sign of the solid at time t, that is the Newton's second law. So for case 1, that is free fall of a solid. So the force acting on the falling solid should be in equilibrium at time t. I'm sorry. By using a sign convention of forces along positive V E x-axis being plus VE, we have uh, the sum of Fx equals 0, that is negative W plus RT plus Ft equals 0. We know from the formula before, that is W equals mg and RT is equals CVT and Ft is equal m dvt over dt. So we can substitute into the equation and we get negative mg plus CVT plus m dvt over dt equals 0. So we get m dvt over dt plus CVT equals mg. So which yield to the following first order differential equations, that is dvt over dt plus c over m times vt equals g, or in other form, that is v accent plus c over m v equals g, with an initial condition, that is vt t equals 0, and we get v0 and the result is 0. So for the case 2, throw up of a solid with initial velocity v0. So for the throw up case, the object is thrown up to the air as shown in the figure. So as in this case of free fall, the force acting on the up moving solid should be in equilibrium at time t. So by using a sign convention of forces along plus VE x-axis, being plus VE for the force, we have the sum of Fx equals 0, that is Fx minus W minus RT minus Ft equals 0. I'm sorry, I think there is a typo. It should be minus W minus RT minus Ft equals 0. So same as before, we substitute the formula of W, RT, and Ft to the equations, and we get negative mg minus CVT minus mdvt over dt equals 0. So we get mdvt over dt plus cvt equals negative mg. So a first order differential equation is obtained, that is dvt over dt plus c over m vt equals negative g. So in other form, that is v accent plus c over m v equals negative g. So with an initial conditions, that is vt, that is with t equals 0, and we get v 0, and the result is 0. So for the next will be explained by Afrian.
Okay, thank you, Aang. I want to continue our presentation. And note that we have the first order ordinary differential equation, that is dvt over dt is plus pt times vt is equal to gt, where pt is equal to c over m and gt is equal to minus g. And then we can make in the other form, that is v prime plus c over m times v is equal to minus g. And then we want to solve this ordinary differential equation. For the first, we want to find the integrating factor. By the formula, we get mu is equal to the exponential of integral c over m dt. And the result is exponential of c over m t. Okay, next. And then we multiply mu in the previous equation, and we get v prime times exponential of c over mt plus c over m v times exponential of c over mt is equal to minus g times exponential of c over mt. And in the left side, we can modify the condition by v times exponential of c over mt prime. And in the right side is similar. And then we integrate both sides, and in the left side we get v times exponential of c over mt, and in the right side is equal to the integral of minus g times exponential of c over mt dt. And the result of the integration, we get minus g times exponential of c over mt times 1 over c over m plus c. C is the constant. And then we have the result is v times exponential of c over mt is equal to minus gm over c times exponential of c over mt plus constant. And then we divide the both side by the integrating factor, that is the exponential of c over mt, and we get v is equal to minus gm over c plus constant times exponential of minus c over mt. So the solution is Vt is equal to minus gm over c plus constant times exponential of minus c over mt. Okay, next. And then the time required for the rigid body to reach the maximum height is called Tm, is the time at which the upward velocity of the body reduced to zero. Mathematically, it is expressed as Vtm is equal to zero. And we consider the previous equation, and we modify the constant by phenol plus mg over c, and then we letting the Vt is equal to 0, and then we get 0 is equal to minus mg over c plus V0 plus mg over c times exponential of minus c over m tm. And then we add the both side by mg over c, and we get the equation become mg over c is equal to v0 plus mg over c times exponential of minus c over m tm. And then we multiply both sides by exponential of cm tm, and we get mg over c times exponential of c over m tm equal to v0 plus mg over c. And then we multiply the both side by c over mg, and we get exponential of c over m tm is equal to v0 plus mg over c times c over mg. And then we multiply the right side, and we get exponential of c over m tm is equal to v0 c divided by mg plus 1. And then for reduce the exponential, we can let the learn. So we get learn exponential of c over m tm equal to learn v0 c over mg plus 1. And we get c over m tm is equal to learn v0 c over mg plus 1. So the result of tm is equal to m over c times learn of v0 c over mg plus 1. Okay, next. The next is the example. An armed paratrooper with ammunition weighing 322 lbs jumped with the initial velocity from an airplane at an altitude of 10,000 feet with negligible side wind. Assume the air resistance of RT the paratrooper encountered with is RT is equal to C times VT squared, in which the coefficient of C is equal to 15. And then we want to determine the first is the appropriate equation for the instantaneous descending velocity of the paratrooper. For point B, we want to determine the function of the descending velocity of Vt. And for point C, we want to determine the time required to land. And the last is the impact velocity upon landing. Okay, next. For the first, the total mass of falling body is equal to m. M is equal to 322 divided by 322 is equal to 10 slot, and the air resistance is RT is equal to CVT is equal to 15 times VT squared. And the instantaneous descending velocity Vt can be obtained by using equation 5, and this is dVt over dt plus 15 times Vt squared divided by 10 is equal to 32,2. And in the another form, we have 10 times dVt over dt equal to 322 minus 15 times Vt squared, with the initial condition of V0 is equal to 0. Okay, next. And then for the point B, The solution of previous equation with the condition in the equation C, we get Vt is equal to 4.634 times the exponential of 13,90 minus 1 divided by exponential of 13,90 plus 1. And the descending distance of the paratrooper can be obtained by the equation 2. And we get the xt is equal to the integral of Vt dt from 0 to t, and it is equal to the integral of 4.634 times exponential of 13,90 minus 1 divided by exponential of 13,90 plus 1 dt from 0 until t. And once the expression of xt is obtained, we may solve for the time required for the paratrooper to reach the ground from a height of 10,000 feet by letting xt times g is equal to 10,000, in which tg is the time required to reach the ground. Okay, next. And last, the impact of velocity can be obtained by evaluating the velocity in equation D at time tg, and we have Vt is equal to 4.634 times exponential of 13,90 minus 1 divided by exponential of 13,90 plus 1. Okay, I think it is enough for our presentation from group 9. From group 6, I mean, I'm sorry if we have some mistakes in our presentation. And if you have a question or suggestion, you can write in our YouTube channel in the commenter column. And in the last, thank you for your attention, and wassalamualaikum warahmatullahi wabarakatuh.